Hi guys, today we're going to do a lesson on completing the square, but before we get started, let's just talk about our transformations. So we're going to get to the graph of g of x equals negative x plus 1 squared plus 3, and we're going to start with the parent function f of x equals x squared, so our quadratic. So the basic f of x equals x squared was our basic parabola that had that key anchor point at 0, 0. This key anchor point happens to be called our vertex. It is the turning point of the parabola. The next piece, throwing in the negative in front, remember all negatives due to the graph is flip them upside down. It keeps that key anchor point, in this case again the vertex, at 0, 0. Putting that plus 1 in there with the x, this will shift us to the left 1. It is still upside down the parabola, but our key anchor point, the vertex, is now at the point negative 1, 0. And then now putting the plus 3 on the end, that's going to shift us up 3 from where we just were. Still upside down because of the negative, but our key anchor point is now at the point negative 1, 3. This key anchor point, the negative 1, 3, is the vertex for this parabola, this quadratic. What's nice about this form, we call this vertex form, g of x, because just looking at the equation, we should be able to tell what the vertex is. You've been doing this the last couple days with the transformations, looking at it when we do the transformation, that key anchor point that we keep moving from 0, 0, it happens to be the vertex every time. So looking at the equation, you should be able to tell what the vertex is. So why don't you take a second, you can pause the video and figure out what the vertex is for each one of these. So for the first one, the transformation is taking us to the left 5 and down 3. So if we think about our key point at 0, 0, we're going to be going to the left 5 and down 3. So that key anchor point, your vertex, goes to negative 5, negative 3. For the next one, while we are doing a reflection over the x-axis because of the negative, and it is getting narrower because of the 4, the only thing here that actually will affect the vertex, that key anchor point, is the minus 1. It is going to shift us to the right 1, so that vertex would be at 1, 0. Only your left, right, up, and down shifts actually affect your vertex. For C, same thing. The 3 is going to make it narrower, the parabola. There's no parentheses, no number inside with the x, so we're not going left or right at all, but we are going down 4. So this vertex would be at 0, negative 4. So now this is that equation that we had where the vertex was at negative 1, 3. It's nice seeing it written like that because we can easily identify the vertex. But if we put this into standard form by multiplying and combining like terms, we would actually look like a different equation. So we would write that x plus 1 twice. That's what it means to square. Double distribute. You would get x squared plus 1x plus 1x plus 1. Combine like terms and get x squared plus 2x plus 1. Distribute the negative in. You get negative x squared, negative 2x minus 1. The plus 3 is still on the end, so then combining like terms, we get negative x squared minus 2x plus 1. So we call this equation our vertex form, and we call this equation standard form. What's nice about the vertex form, like I said, is that you can easily identify the vertex and what the transformation is that is taking place. In standard form, unfortunately, it is a lot harder. Today, we're going to be starting with the standard forms. So it's going to be multiplied out. And our goal is to convert this into vertex form. We do that by completing the square. So you did completing the square in Algebra 1, a little in geometry, and again in Algebra 2. So it's going to be the same process, only we have this f of x or y in the equation that we have to deal with. So the first step for completing the square is to isolate the x's. So the x squared minus 6x I want to get by itself. So I'm going to subtract the 8 to the other side. This f of x or y cannot actually combine with the negative 8, so it's just going to stay f of x minus 8. And now we have the x squared minus 6x by itself. The next step is going to be to use that formula, b divided by 2 squared, and add it to both sides. Remember, the goal for completing the square, if you think back to the last few years, is to create a perfect square trinomial, which you'll see in a second. So here, my b value is always the number that is left over on that side with the x's. It's the number attached to the single x. So in this case, b is negative 6. So negative 6 divided by 2 is negative 3. And negative 3 squared is 9. And we are going to add the 9 to both sides. So on the left, we can combine like terms. Negative 8 and positive 9 is positive 1. And on the right, you just created what we call a perfect square trinomial. So this x squared minus 6x plus 9 is called a perfect square trinomial because you should be able to factor it and get the same parenthesis both times. It should be the same factor twice. So you're factoring the side with the x's. You get x minus 3, x minus 3, adding to negative 6, multiplying to positive 9. And then another way to write this, because we call it a perfect square trinomial, another way to write it is x minus 3 squared. The last step is to isolate the y or f of x. So subtract the 1 back over. And we get f of x equals x minus 3 squared minus 1. So this is now in our vertex form. So unlike the original equation, vertex form, you should now be able to tell me what your vertex is. Positive 3, negative 1. It's shifting to the right 3 and down 1, and we should be able to get our graphs like we were doing the other day. So we're going to practice that now. This says rewrite the following quadratic functions into vertex form by completing the square. And then we're going to also practice today finding the x and y intercepts to graph. So the last few days we've been moving the anchor point and getting our tables that way. Today we're going to find x and y intercepts and practice that. Okay, so rewriting. Remember, step 1 was to isolate the x's. So I'm going to add the 7 over to the other side. From there, I can take the b value, divide it by 2, and then square it. So it happens to be -6 again. That b value is always the number that is left over with the x's. It's going to be with the single x. So you should get a +9 that you are going to add to both sides. So now the right side, or left side, I can combine like terms and get 16. The right side is that perfect squared trinomial, so I'm going to factor it now already. am adding to -6, multiplying to -9, +9, is x minus 3, x minus 3, which is just x minus 3 squared. If you want to go straight from the trinomial down into the squared piece, go for it. And then last step is to get that f of x by itself again. So we get x minus 3 squared minus 16. Okay, so our vertex we can get from this equation. It is +3, -16. However, I also want us to practice today the x and y intercepts. With the vertex, you could always center it in the table and graph it like we've been doing the last couple days, where you would make your table, center that point, and choose 2 values on either side to plug into the equation. But we're just going to practice our x-intercepts and our y-intercepts. So if you are an x-intercept, you are hitting the x-axis, which means your y is 0. So you're going to actually want to go back to the original equation for this. Your x-intercept is best found from standard form. So my y is the f of x. I'm going to make it 0. And now to solve this, you are factoring the original equation. So adding to -6, multiplying to -7 is x minus 7, x plus 1. Doing your little t-chart, setting each of these factors equal to 0 and solving. You get a +7 and a -1 as your 2 x-intercepts. For your y-intercept, your x is 0. It does not matter if you use the original equation or the vertex form equation. I do think that the standard form, the original equation, is a little bit easier, because if you plug in a 0 for all of those x's, they should all cancel out to 0, and you're just left with the constant on the end. So now graphing, we're going to use this information to graph. I need to put my vertex. That's going to be my turning point. I'm going to need to put my x-intercepts and my y-intercept on the graph. We know that this is a parabola, this is our quadratic, so connecting with a U shape, you should be able to connect the points into your parabola shape. So rather than use the table, today we're going to be using our x and y intercepts.